As we mentioned before, there are two different ways to extract JSON data in SQL Server. One is for JSON path and the other option is for JSON auto. For JSON path is very similar to for XML path. Um, the for JSON path will be able to generate the JSON data based on column notation system, and it converts the key columns into keys and the rows into values. So we look into this in more detail with some simple examples and understand how the rows and columns are transformed into keys and values, and how you can represent complex relationships in relational data into a JSON data using nested objects and embedded objects that we discussed in the earlier slide. So if we go back to the SQL Server, I'm using the SQL Server 2016 here and with AdventureWorks sample database. But before we dive into the actual tables and queries, let's look at some simple examples to understand the concepts of JSON in SQL Server. So this is a simple select statement with one row, one as a product ID and Apple as a product name. So if yes, if I execute this, yes, I'll get a simple row with a column and with two columns with one row. I can just add for JSON path to this query and convert this data into JSON. So it converts the columns into keys and the values into rows into values. So if I execute this and I can paste this here to be able to clearly see the output. So the product ID is a key and product name, and product one is a value and product name is a key and Apple is a value. So it it's an object where you have two key value pairs enclosed in an object, and there is an array. Although there is just one single object, by default SQL Server encloses a square bracket to the output, to the JSON output. um, it doesn't matter if it's a single document or more than one document, but you can change this. We will look into this in the later video. So as I mentioned, in the slide, that the for JSON path has an ability to transform the column the dot based notation system into a complex JSON data. So here I just added a dot for in the product dot ID in the and dot for the product dot name. So I just added a dot between these two in these columns. So if I run this query, you will see a different output than the output before, because all we changed is a column alias, nothing else, is everything is same. So if I run this query, and let me just paste the output here, you can see here the product dot and the product dot. So it transformed the product as a root of this object, or like a parent key, and the ID and name are enclosed in a object, and those become the value for the product key, and they both are enclosed in a another in an object, and the array wrapper is common. So you can see how by simply changing the column based notation system, we completely transform the data into a different, it has a different whole different set of schema, JSON schema, compared to the earlier one. If I just add another uh, key here in the column notation like AdventureWorks, and if I run this same query again, I'll get a complete different output. So you would expect, so what you would expect is you will have AdventureWorks as a part of the as another key here, something like this. And this will be enclosed in a curly braces. So let's verify whether we are correct or not. So if I run this and if I paste the output here, yes, we are absolutely right. So the AdventureWorks dot product dot ID, where the adventure becomes like the root, and the product becomes the sub object, and the ID becomes the part of the entire object. So this is like a nested object that we just saw in the previous example. So the, the ability, this is a, I mean, the ability for the JSON path to convert this into JSON data is a wonderful feature that allows the programmers to dynamically transform, into a lot more um, easy way to transform the data into JSON. So, I mean, if I just declare a table of products and insert two rows into it, and if I just look at the output, so if you have two rows with ID and name and apple and orange, and if I extract the JSON data here, um, you would see, two key value pair documents separated by comma. So objects. So for example, here there is this one row, and there is this, sorry, there is a second row. So these rows are separated by comma, and each columns are represented as a keys, and the value, and the rows as values, and everything is enclosed in an array bracket. So this represents an array of objects. So a table, if you query a table, each row represents an object, and those are enclosed in an array. That's how you represent a table in a JSON document with a simple example. So now you understand the how JSON path transforms the relational data. Let's look into some more complex examples. And one more important thing that I want to mention for JSON path is that without the column names, JSON path will not be able to generate the JSON data. So column names are important, those are the keys. So if I run this query here, you will get an error saying the the unnamed columns cannot be used as keys. So that's the most important requirement for the JSON, extracting a JSON data is you have to have the column name. So while we were just saying that, that we need to look into some complex, little more complex example to understand, how you can transform like a, one to many relationships or many to many relationships into JSON documents. So here I have a simple example, this is something that I took from the slides, where you have a person phone, and person phone type, phone number type. So these two so th- this the all these four five columns are coming from the person table, and this one is coming from person phone, and this is coming from person phone type. So you can see a person has more than one phone, and which is a different type. So in a relational data, you will see the duplication of these five values the five columns. So when you transform this into JSON, JSON data is all about denormalizing. You have to the duplication should be removed from JSON data. Otherwise, there is no benefit of using JSON. You know, it adds a complexity of again having another layer to parse through these additional duplicate objects and transform it into an actual object that you want to look. So to be not be in that situation, we need to convert into a JSON document where there is no data duplication, and using the nested objects concepts and using the embedded objects concepts, whatever it is, we have to convert this data into a proper JSON format. So like I mentioned before, we can just add for JSON path to an existing query to transform the JSON data. So here I have this query where I'm joining the person phone number type, and business entity ID, which we just looked here. So if I add for JSON path, and let me copy this output. I would not paste this in the management studio because it's a big document, and it's visually you will not be able to identify the things that I want to discuss. So for this, I'm using an application called Json Editor. It's a part of the Google Chrome, where it will allows you to edit the JSON document, and look at the JSON document and format it if needed. So let me go ahead and open it. So you can, this is a free app, so let me paste the document here, and I'll click the format button, and it transforms the output. So you can see here, each row represents as an object, which we talked about. And so the only difference between the first object and the second object is the phone number and the type. Everything is same. So it's the same person, but as a JSON, as we just mentioned, JSON's, each row is represented as an object, and the entire thing is, we can call it as a document, where you have multiple JSON objects together, becomes a JSON document, just like an XML document when you do using for XML path. So we need to transform this into a something that we saw in our slide, just like this, where we transform the we eliminate the duplication of data, and we use the concepts of embedded object, and be able to embed these two different phone numbers or types into one. If you have more than two or more than three, whatever it is, they have to come inside this phone key. So in order to achieve that, what you would need to do is using the subquery concepts. So what you what you do is you query the data you need. For example, the phone number and the type, and you query the data as a JSON, and then you attach the JSON data, and once you denormalize that data, and you attach that to the actual the person, which is the business entity ID, title, first name, middle name, last name. These are the four columns that define the attributes of a person. So we'll attach that JSON object to these rows, and again transform this into a JSON document altogether. So how I do this is, first of all, if you observe this, this is my actual data, and if you observe this, I'm using a subquery, and in that subquery I'm transforming it into a JSON document. For that, I'm just transforming the phone number. So if I look at the output here, you would see something like this. So the phone column, which is a subquery, a correlated subquery, attaches to the actual row data, and for each row you can see we are eliminating the duplicates here. So we only have one Ken, but we have his both the phone numbers as a JSON document attached to the phone column. So if I extend this join here inside the subquery to include the phone type, it would look something like this. So I just added a phone type to this already, the JSON document, which we are adding to this four columns. So you can see, I just added a phone type. So now you have your, now you denormalized your data, and now you just convert everything into a JSON document. So if I run this, it will create a complex document. So if I paste this into, let me go ahead and open another application here, another JSON editor. So let me paste this here and transform it into a format output. So I'll open the first query we wrote versus the second one. So you can see there is a significant difference between the output. So here we have, let me change this into top 3. So if I run this, and if I paste this into the document here, and if you look at the output of the one with has just the joins, and we added the JSON path, and the difference here, we are able to achieve our goal using the JSON path and subqueries. Somehow we were able to transform this duplicate JSON document into an exact well formatted JSON document. So that's how you use for JSON path to transform the data. So there is, like one more thing. If you observed clearly, you can see, if I query this using without for JSON path, I'm seeing the title null. If I query with JSON path, I'm not seeing the title again. So by default, SQL Server will exclude the null values from the JSON output. So the only way to include them is using an option called include null values. If I run this query, and let me just paste this output here so we can compare the output of one with the nulls. So if I run this query again and if I paste this document here, if you can see here the differences between there is a title null key value pair in the first document, it's not. So having this include null values will make sure that your null columns or rows, the rows which have null values will be able to present in the JSON object. So then another simple examples here, I'm looking at the sales orders information in the AdventureWorks database. So there is a sales order header and sales order detail. The sales order header contain the order header information like order number, order date, and the sales order detail contain the order, the product name, the unit price, and the order's quantity. So if I run this simple query here, and you would see, 6 rows, so sales order number 702 has 2 rows, and you can see there are 2 different products, and so basically this order contains 2 products and with the unit price and quantity, and the order number and the date is same. So this is the duplicate data, like we mentioned before. If I add the JSON path to right away to this query, it will not be the JSON document that we want. It would be, the data will be duplicated in the JSON output as well. And the same trick we use here. We create a I mean first of all, before we actually create, I would like to explain, like we talked about, how we can use the column name as a notation system to be able to transform. So I'm adding the order detail dot here. This will help. This will create a an encapsulation for these three, but still there is duplicate data. So you know that's the you still need to use the subquery method to first get the detailed data and then attach that to the actual data of the actual query of the whatever that, for example, the order number and date, and then these will be a subquery. So one more other option is, sometimes that you can do is adding a root element. So what I mean as a root element is, if I look at here, yes, you will see bunch of data here, and if I copy this in the JSON editor, you will see bunch of data coming through from the SQL Server. But as a table, you have table name. The table name represents what data contains in the table. So the similar way, we can attach a what's called like a root element using the option called root, which is very similar to how you do in XML. um, you know this will add the root element orders to the output, so that will tell you the user that, hey, if you look at this data, you will not understand what this is all about. So if I paste this here, you would be able to understand that we are talking about a what's called order. So what it does is it puts everything in an array, and then it encapsulate this in what's called orders, which what we mentioned in the root. So you can see the difference between these two here, one without the root and one with the root element. So that's simple tricks to how you can easily add or change, include null values or add root element. There's a simple tricks to be able to transform your JSON output. So that's so here, just to kind of visually represents what we talked about, how we represent the order detail dot product name and all. So you can see here the object here contains another object, embedded object. With that, you have the order detail, you know um, with the product name and unit price. I mean, you can simply change this into something like, let's say, you know adventure work. works. So if I paste this here, you could you know you could see a document with with so if I do this, then you would expect something like this. Everything is enclosed in a JSON object, and everything will be part of the key called adventure works. So that's how this particular output looks like. So I can run this query and see that. So the adventure works, and then an open bracket, and everything is inside another, inside the value of the adventure works. So that's you know that's how you use the subqueries to actually denormalize the data when using for JSON path. So let's look into for JSON Auto. For JSON Auto is a lot different to for JSON path. I mean, it still transforms the relational data into JSON data, but it the way it does is it uses the join the tables that are being joined, and the order which are there joined. I mean, the order doesn't matter, because if there is a relationship, like a foreign key relationship between them, but if there is not, then you have to join them in an order. So if, let's say, if we have a foreign key relationship between the primary key and the child table, so the primary table and the child table, so in that situation, it will use that relationship as a way to transform the data, and it also looks at the column position, where the columns are positioned in your select projection query. So the same example that we just talked about, using the person and person phone and phone type schema, we have this data, and if you just add the for JSON Auto to this, without any need of um, you know subqueries and everything, you will have the data how you want. But considering one thing here, because the phone type is another join here, it considers this as another object completely by itself. So that's fine, but my goal is to show you here how JSON Auto transform the relationship that might exist in the database into a logical, into a document that represents the relationship directly. We are not using any subqueries, we are not telling it how to do it, but by just specifying this, it will automatically does that. So if I look at the JSON here document, so you can see the phone, inside the phone, you can see there is no repetition here. So the business entity ID is just one time, it comes at once, and there is two. So the duplication is gone. So we successfully denormalize the data using for JSON Auto without any need of subqueries. But for JSON Auto does not allow you to do any customizations. So if we look at this data here, you can see that there is something that's called PT, which is weird. That's something that we don't want to see there. It doesn't, it's not properly named. So where does it come from? So that particular word comes from this, the alias that we given to this table in this join. So now, so 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 the for JSON Auto also uses the table, the aliases that we are using here, to transform the output. So for example, um, if I would change this into something called phone type. Okay, let me change this to phone type, and if I'm going to change the join also here, and if I run this query again and paste this in another output here, you will see I was able to rename that particular into what's called phone type. So now you understand how the for JSON Auto transforms the data, using the joins, using the and the table aliases that we use in the joins, using the column positions, where the columns are. So if the same thing that I would apply for this example, sales order, which we looked in the JSON auto. So by default you would get this data like this. So there is order number, um, let's say. So we have like a five documents here, and um, let's say, let me just order this by sales order number. So if I run this query, sorry, without the JSON auto, so you see here, let me change it to, okay. So I mean, you have two orders here. So for example, 3659 has 12 item details, and and there is another one with 660 and 661. So anyways, in normally, if you use the for JSON path, you need to use this just subquery, but as for JSON path, you will be able to transform the data directly without any need. So you would only see one object with order number, and all these values here, the detail, are part of an embedded object. So if I run this query here and copy this output into the JSON formatting, JSON formatter, so you can see here, I just added for JSON auto, nothing else. I did not do anything. So by using that, I'm able to generate this denormalized JSON data without much of the hassle of using subqueries and all. The way the subqueries help you in for JSON path is, you have any custom logic that you want to put, where you want to transform in a particular way, you want to keep this as a nested object, you want to transform it as an embedded, that's how for JSON path helps you to do that. So on the whole, the differences between the for JSON art and auto and for JSON path are significantly a lot. So you need to understand what those differences are and where you can use the which option. So JSON auto for automatically formats it based on the column position and joins, whereas JSON path creates a JSON output based on um, you know the column notation system and the path. So if I look at these two queries, you know there's that there are two same queries here, but the only difference is, for one I'm extracting using for JSON auto, and other one I'm using for JSON path. So let me run these both queries, and I copy this output here, and then do the same thing here. I would copy the output here to visually see the difference. So so here you can see, we the for JSON path, it still does not automatically remove the duplicates, whereas the for JSON auto automatically does. So that's first, one of the most important difference is, it automatically transform the JSON auto is very simple. By just adding for JSON auto, you're eliminating the lot of work of creating subqueries and using for JSON path. So that is one first difference between the for JSON auto and path. So here is another example, similar way, the for JSON auto and how for JSON path works. That's I can run this, but it's still the same. Like I mentioned, um, the for JSON auto removes the duplicates, and transforms, creates a denormalized document, whereas for JSON path still has a duplicates. You need to use subqueries. So there is another option that we talked about before, is how you can get, for example, if this is the particular query, the simple, it has two columns, and if I add for JSON path, it looks something like this. It's a single document where um, you know so you don't need so without even the square brackets, it is still a valid JSON object, because everything is enclosed inside the object by separated by comma. So you have a object with a key value pair, multiple key value pairs. So let's say you want to remove those square brackets, these which are arrays. So if I do that, if I add an option called without array wrapper, it automatically removes that for me. So if I execute the output here, so you will not see that. So if I run with the JSON path, you will see that. So the difference between the sorry the difference between the without array wrapper and with array wrapper, so here, so you can see the difference. So here, that let me actually show you the last slide which I wanted to present, is the difference between the for JSON auto and for JSON path. So this is the same query that we showed you, sorry, same that we showed you, exactly shows what the differences are. So you can visually see the how for JSON auto removes the duplication and transforms into a denormalized document, whereas for JSON path, it uses the column based notation system to create embedded or nested objects, and then you have to use subqueries to denormalize the data. So here, this conclusion of this video, hopefully you understood how to use for JSON path and for JSON auto, and how you can transform a one to many or many to many relation data using for JSON auto or path, and understand the differences between them, the pros and cons, and hopefully you will be able to play with this and understand in detail, in a more bit detail. Thank you.